This video is going to be on the graph of y is equal to tan of x and everything that you need to know associated with that graph. It will correspond to lessons 6 and lesson 7 in your workbook. So if you can open up to page 547 in your workbook, and we will graph y is equal to tan of x. So how you always want to start your y is equal to tan of x, sine of x, or cos of x, draw your Cartesian plane and put on your 4 points on the quadrants. So 0, 90, 180, 270, 360. Let's graph this first one, which would be y is equal to the tan of 0 degrees. So I've got it down here, y is equal to the tan of 0 degrees. Remember that tan is y over x. So if I go to 0 degrees, so 0 degrees would be right here, it would be y divided by x, so 0 divided by 1. 0 divided by 1 is 0. Okay, so what that means, when x is 0 degrees, my y value is going to be 0 as well. So the tan graph is going to have an x-intercept right here. Now let's find out what happens at y is equal to the tan of 90 degrees. So let's go up to 90 degrees. Tan of 90 degrees is y divided by x, so it's 1 divided by 0. And remember, we cannot divide by 0, so at 90 degrees, tan is going to be undefined. So at 90 degrees, tan is going to be undefined. And basically, I'm just going to put a square here. Tan, remember, is going to be undefined there. So how I'm going to show that on my graph is at 90 degrees, there's a vertical asymptote on your tan graph. X cannot be equal to 90 degrees, so we have a VA there. Okay, let's figure out what y is equal to the tan of 180 would be. So at 180 degrees, tan is y divided by x, so 0 divided by negative 1. So at 180 degrees, 0 divided by negative 1 is 0. So again, at 180 degrees, we have an x-intercept. Let's do 270 degrees. So tan of 270 degrees would be y divided by x, negative 1 divided by 0. And again, we're undefined. So at 270 degrees, we are going to be undefined. 180 was 0. It didn't ask for 270, but 270 is undefined. So again, wherever it's undefined is represented with a vertical asymptote. And then even though it didn't ask for 360, let's figure out what the tan of 360 degrees would be. So one complete rotation around the circle would be here. Tan of 360 would be y divided by x. 0 divided by 1 is 0. So another x-intercept here. Okay, let's figure out now the tan of negative 90, right? So negative 90 would be right here. Tan of negative 90 is y divided by x, so negative 1 divided by 0, undefined. We're always going to be undefined for tan at these 2 points. So negative 90, we're undefined. So again, get your ruler. Negative 90, we're undefined. Negative 180 would be over back up here. Y divided by x, tan of negative 180, 0 divided by negative 1 would be 0. So I've got an x-intercept here. We're going to have an x-intercept at negative 360, and we will be undefined at negative 270. Okay. So how are we going to connect, like what does the tan graph look like? Because I can't connect these 2 points because we have a vertical asymptote, which means that my tan graph is going to go through this point, but it can't touch or cross this vertical asymptote. So what does the graph of y is equal to tan of x look like? So we're actually going to type it into our calculator, and I'm going to show you a new button that's going to be super helpful with graphing, and it doesn't matter if you do this for sine of x or cos of x, but it's a new button that will be very beneficial. So we just need to make sure that we're in degree mode on our calculator. And actually, we're going to set our window from negative 360 to 360. Let's figure out what one box is worth. So one box, count how many boxes to get to 180 here, and then we're going to count how many boxes does it take to get to 180, and we'll divide by that many boxes. So starting here, 5, 6. So essentially what that means is that one box is going to be worth 180 divided by 6, which is 30 degrees. And you could sort of count to verify. And then 90 would take you to 180. Okay, so take out your calculators and make sure that you're in degree mode. Type in the tan of x. If you just graph without changing your window, right, we're on a regular 10 by 10 window, and if you just hit graph, this is what you will see. So we want to see this as a trig graph. So what I want you to do is I want you to go to zoom, and then we're going to be we're going to be graphing a trig function. So just hit number 7, and it will actually adjust your window to see the graph. This is actually what the tan graph looks like. Now we want to further adjust our window to go from minus 360 to 360. Okay, so I want to further adjust this window. So I'm going to go to window. Right now it's going from minus 495 degrees to 495 degrees, but I want to go from minus 360 to 360. And I want my scale to go up by 30 degrees. Then my y's, this graph is going 13 to negative 13. So negative 13 to 13, scale of 1, and let's graph this. So here are my x-intercepts. We had 0, we had 180, we have 360. This would be negative 180 and negative 360. We have vertical asymptotes within our graph. They're invisible, right? But they're vertical asymptotes. So this will sort of show you what the shape of a tan graph looks like. So if I were to graph it now, what's going to happen is the shape of a tan graph will be this. So this is what a tan graph will look like. So very different from a sine graph or a cos graph. Okay. Now, one of the questions it's going to ask right away is it's going to say, is this graph periodic? Does the picture repeat itself over a given interval? And it does. This is a periodic function. So this piece of the graph, right, this repeats itself over here. And this piece repeats itself over here. So what is the period of a tan graph? A sine graph and a cos graph. Remember, it repeated itself every 360 degrees. That was one period. So what happens is if I go from 0 to 180, that's 180 degrees. That's how often a tan graph is going to repeat itself. So from here, if I add 180, I'll get here. Add 180, I'll get here. The period for a tan graph is 180 degrees is what the period of a tan graph is. So different from a sine and a cos graph. Okay, flip your page and let's answer a couple of questions. So again, next to number 7, I just want you to draw a very quick tan graph. So what do we need to remember for a tan graph? We need to remember that at 90 degrees, we have a VA. So this is at 90 degrees and at 270. There's vertical asymptotes at 90 and at 270. That means there'd also be a VA at negative 90 and negative 270. The x-intercepts of a tan graph were 0 and 180 degrees. So remember the period. So 0, add 180, and we'll get over here. So this is 180 now. So x-intercepts are at 0 degrees, 180 degrees. If you add from here another 180, where will you be? You'll be at 360 degrees. That's another x-intercept. So this is what a tan graph looks like. If I said, where over here would your next x-intercept be? It's every 180 degrees, right? So we are going to go 180 degrees in this direction. It'd be negative 180 degrees. So this guy would be negative 180 degrees, and it would look like this. Okay, so this is what a tan graph is. But what you have to remember is where are the VAs and where are the x-intercepts? The domain of this. How are we going to write the domain of this? Oh, and they are actually giving me a restricted domain. So they only want me to basically look at from 0 to 360. So how would I write the domain of this? So how we write the domain of a tan graph is we say x is such that. Now x could be any number from 0 to 360 except for the vertical asymptotes. So from 0 to 360, x could be anything except for 90 and 270. So we will write the domain as x cannot be equal to 90 degrees or 270 degrees, but other than that, x belongs to the element of real numbers. The range of a tan graph, it goes forever down to negative infinity and forever up to positive infinity. So the range is YER, or negative infinity to infinity. The period of a tan graph, we have to remember this. This shape repeats itself, it's periodic, it repeats itself every 180 degrees. So the period is 180 degrees. The y-intercept of a tan graph is right here, and that is going to be y is equal to 0. The x-intercepts, so what were the x-intercepts? Well, 0 degrees is an x-intercept, 180 degrees, every 180 degrees, 360 degrees. It only wants me to give the x-intercepts within this domain, but I could add from here, add 180, and you'll be getting all the x-intercepts. The equations of the vertical asymptotes within this domain are, I've got a VA at, so what's the equation of this line? The equation of that line is x is equal to 90 degrees, and the other vertical asymptote is x is equal to 270 degrees. Okay, now let's look at questions 8 to 11, and 8 to 11, they're referring to a tan graph. So look at what this one is saying. The domain of a tan function, and now they're actually talking about like from negative infinity to infinity. So if you look, this domain here, like which one of these would fit the domain of this guy? So this one is saying x cannot be equal to pi. Okay, so pi is 180 degrees. Well, x could be equal to 180 degrees, right? Those are x-intercepts. This is saying x cannot be equal to pi, and then multiples of pi. So it can't be a. Look at what b is saying. The domain x cannot be equal to pi over 2, and then n just means multiples of pi over 2. So pi over 2 is 90 degrees, right? So x cannot be equal to 90 degrees. Now that is true, okay? So it can't be 90 degrees, but it also can't be 270, and then it can't be 180 past that. So what's the difference between B and C? So what C is saying, x can't be equal to pi over 2, so pi over 2 is right here, plus multiples of pi. So if we're at pi over 2, plus I add pi, I'll get here. So pi over 2, if I subtract pi, I'll be here. So the answer, the way that this is written, is the domain is actually going to be this. The domain could be any number except for the vertical asymptotes. The vertical asymptotes are at 90 degrees and then plus every 180 degrees. And that's what this one is saying. Number 9, the asymptotes of the graph are. Okay, so I know that there's vertical asymptotes at x is equal to 90 degrees. And then the next vertical asymptote is going to be, so 90 degrees. If I add 180, I'm going to be at the next vertical asymptote. So I'm going to add 100 multiples of 180. This is where the vertical asymptotes are, 90 and then multiples of 180. So there's vertical asymptotes at pi over 2 plus multiples of pi. The range of a tan graph goes from negative infinity to infinity. So it would be YER, YER. D would be the answer. The zeros of a tan graph, okay, so where are the zeros? 0, 180, 360. So let's write the zeros. The zeros of a tan graph are 0, 180 degrees, 360 degrees. Multiples of 180 degrees, okay? So which one of these would take care of all of these zeros? So 0, 180, 360. Can't be this one. This would be telling me that a 0 is at pi over 2, which is 90, right? So it can't be this guy. This one is telling me that zeros are at 90 degrees and then multiples, like, and then add 180. That would be the VAs. So it's not this guy. This one is telling me every, like, pi, like multiples of 180 degrees, which is what it would be, right? Because if n is 0, we would be here. If n is 1, we'd be at 180 degrees. If n is 2, we'd be at 360. So this answer is A. Okay, so that's the tan graph. Let's do a couple of the A and B value on a tan graph, because again, it's going to be different from a sine graph. So lesson 7, I want you to go to page 552. Okay, so for a tan graph, again, let's just quickly do a sketch of a tan graph. 0 is an x-intercept, 90 degrees is a VA, 180 degrees is an x-intercept, and 270 is a VA. Negative 90 is a VA. 360 is an x-intercept. So what a tan graph looks like is this. X-intercepts, 360 degrees, 180 degrees, 0. So what do we need to know for a tan graph? With a tan graph, the period of a tan graph is 180 degrees. So with a sine or a cos graph, remember the period was 360 divided by b, or 2 pi divided by b. With a tan graph, it's going to be 180 divided by b, or pi divided by b. Okay, so the period is different. This repeats itself every 180 degrees. The amplitude is actually not going to be applicable in a tan graph. In a sine graph, right, or a cos graph, if the amplitude is 5, it's going to tell me that it has a max of 5 and a min of 5. We could still have an A value in a tan graph. So we could have an A value here, and that's fine, but it doesn't affect, it will affect our mapping, right? X over B, A times Y, but it doesn't affect the amplitude like this guy does. So we just need to understand this. Okay, let's look at a couple questions that will involve tan graphs. So the first question is class example 3. And it's this guy here. So remember the equation is y is equal to a tan b of x. So this graph, it says they want us to draw a tan function having a period of pi over 2. So remember that the formula is period is equal to. Now normally, if this was sine or cosine, I'd say 2 pi divided by b. But the period for a tan graph, it is pi divided by b. I want to get b by itself, so I'm trying to figure out what b is. So the equation for b is equal to pi divided by the period. B is equal to pi divided by the period. They tell me that the period is pi over 2. B is equal to pi times the reciprocal. Pi's would cancel, and b is equal to 2. So my equation, the amplitude, we're just going to, or sorry, the a value, so no amplitude, right? The a value is just going to be, is there a vertical stretch? It's just a 1 if they don't tell us. So it's the tan of 2x. That would be this equation. Okay. Let's look at a couple homework questions with tan in it. So state the period in degrees. So again, when we were doing this one, right, remember that period, if it's sine or cosine, is we're doing degrees. So 360 degrees divided by the b value. So this period would be 360, the b value is a 1. This would have a period of 360 degrees. It's different for a tan graph. The period of a tan graph is 180 divided by b. The b value is 3. That means that the period is 180 divided by 3, and 180 divided by 3 is 60 degrees. So what this tan graph would be is it would have an x-intercept every 60 degrees. It would have an x-intercept at 0, at 60, at 120. Those would be the x-intercepts, okay? This one, again, it's a tan graph. So the formula for period is not 360 divided by b, it's 180 degrees divided by b. That would be 180 degrees divided by b is 2/3. You could do 180 degrees divided by 2/3 in a bracket, or that's the same thing as 180 degrees times 3 over 2 times the reciprocal of this, and that would give you 270 degrees. So period is 270 degrees. So again, this graph, we'd have an x-intercept at 0, then we'd have an x-intercept at 270, then you'd add 270, and that would be your next x-intercept. That would be for your tan graph, okay? State the period in radians. So let's just do B really quickly. This is a cos graph. So remember that, so period is equal to 2 pi over B. B is equal to 2 pi over the period. That's your formula. B is equal to, oh, they gave me the B value, so we're finding the period for this one. I didn't need to do this. Period is equal to 2 pi, b is 3. That would be my period for this cos graph, 2 pi over 3. Tan, though, you say it's got a different period. Period is pi divided by b. That's the period. Period is pi divided by the b value is 1. That means the period of this graph is every pi radians. So you'd have an x-intercept at 0, and then at pi, and then at 2 pi, every pi radians. This one, again, period. You say it's a tan graph. Tan is pi divided by b. Period is equal to pi divided by 1/2. Pi divided by 1/2 is the same thing as pi times 2, so the period would be 2 pi. Try number 7. Okay, so pause the video, see if you could write the equation in y is equal to tan of x. What's the b value if you have that period? What's the b value if you have this period? Okay, so period is pi, it's tan. So it's no longer 2 pi divided by b, it's pi divided by b. B is equal to pi over the period. Actually, for this one, it's not going to be pi because this one's in degrees. So I need to change this to 180 and this guy to 180. Okay, B is equal to 180. The period is 45. This will cancel. 180 degrees divided by 45 degrees is a B value of 4. So there would be a 4 in front of the B. This one, the formula for B is 180 degrees divided by B, or we're in radians. So pi divided by. Now my B value for this one, B value is pi divided by period. B is equal to pi divided by 4 pi over 3. B is equal to pi times the reciprocal of this. That should be 3 over 4 pi. And pi's will cancel. And we're going to get a b value of 3 over 4 for this one. So the equation would be y is equal to the tan of 3 over 4x. Okay, there is one last tan question. Actually, there's 2 tan questions. So 14 is a good question. So again, pause the video, see if you could do 14, and then I'll do 14. So again, this one, which of the following functions does not have a period of pi? I'd have to go through each one. So period is equal to, now this is a sine graph. So the formula for sine is 2 pi over b. The b value is 2 here. So 2 pi over 2 pi. This one has a period of pi, so it's not the answer because it says which one does not have a period of pi. Okay, let's do this one. This is a cos graph. Period is 2 pi, it's a cos graph, divided by b. B is 2. 2 pi divided by 2 is pi again. This would have a period of pi. That's not the answer. We have a tan graph. The equation is different for period. Period is equal to pi divided by b. Pi over 2. This graph would have a period of pi over 2. That is not pi. This would be the answer. Let's check this one though. The b value is 1 here. The formula for period is equal to pi divided by b, pi over 1. This guy has a period of pi, so D is not the answer. Okay, the last one that I want you to do would be this one. So what I like about this graph is I want you to, first of all, if you could figure out what one box represents, because that's sort of, some students have a hard time figuring that out. So what is one box worth? So how I'd figure that out is I'm going to count how many boxes it takes me to get to pi, and then I'm going to divide by that number of boxes. So starting from here, it'd be 1, 2, 3, 4, 5, 6. One box is worth pi over 6. Okay, that's what one box is. So it's just good habit to be able to count. Now, um, we could double check by saying here's 0, this is 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6. Now the period, you should actually be able to look at this and figure out what the period is. So here's my first x-intercept, and then it repeats here. What distance is that? Because that would be your period. So we're going from 0 to 2 pi. The period for this graph is 2 pi. Okay, so we need to understand that. It wants us to figure out the b value for this graph. So the formula is period. Now it's a tan graph, so it's pi divided by b. B is equal to pi divided by the period. B is equal to pi, the period was 2 pi. Pi over pi will cancel, and b is going to be 1/2. And it says, what's the value of b to the nearest tenth? Well, 1/2 would be, we're basically getting y is equal to the tan of 0.5x. So the answer is 0.5. What I want you to do, sort of the last thing, that's the lesson, but see if you could punch this into your calculator and if you could get this exact window. So punching this into my calculator, I want to be in radian mode. Okay, so I'm going to go to mode radian. I want to type in the tan of 0.5x. And then before I change my window, I actually just want to go to a zoom and we're going to do a trig function, so 7. So this is how it graphs it for me, which is pretty close, except I want to change my window to what they have here. So I want to change my window to, that looks like minus 5 pi over 2. So minus 5 pi divided by 2 all the way to 3 pi. And remember, one box we said was pi over 6, so that's my scale factor. And then my y's, it doesn't tell me, but I'll go from -10 to 10. And then just see if it looks like this guy. Three periods it's showing. And so is this. And that's pretty much the lesson.